Firebase applications. We've written an SDK for you in iOS, Android, mobile web, lots of other frameworks. And that SDK communicates to the Firebase service. There is no intermediary gatekeeper. There's no servers. Google handles all that for you with a suite of tools that are called directly from the SDK itself. Very powerful managed services that allow you to focus on building an app rather than working on all the boilerplate. So we have authentication, we have a real-time database, we have cloud messages, and lots more products there. And really, it's to empower you to deliver products faster without worrying about all the DevOps and stuff like that. There's also the real-time database. How this is differentiated from a traditional database is the real-time database synchronizes changes to all the listening clients, all the clients that are interested in a specific spot in the database, in milliseconds. And this allows you to build very rich applications for free with Firebase. None of this, having to spin up servers and juggle sockets and lots of complicated things. So it's a nice little, addition to the Firebase product. And if you were to build your own servers, you'd have to build all that as well. But there are problems in this thick client model promoted by Firebase. It's not without its disadvantages, right? So while Firebase gives you a very powerful tool to validate the data coming into your database, to validate the users reading files, this is our rules engine, there are things that you can't quite do in Firebase without Cloud Functions. So say you wanted to perform an expensive operation. You want to resize an image or transcode a video. This is something that would burn up your user's battery, very likely to uninstall your application if you do that. And just, it's going to make your application slower. And again, it's just a lot of complexity. It's just shifting that complexity to the clients. So now you need to know how to resize an image on iOS, Android, and then you're going to have to do it on the web through all kinds of trickery. So say you didn't want to trust the client. The real-time database has a very powerful rule set, but you can't encapsulate everything in there. Say you wanted to moderate images. Say you wanted to filter out adult language. What if you have secrets? What if you have private keys, API tokens, things that you don't want on the client? Clients cannot be trusted, right? It's just an application on their phone. It could be cracked open. They can look at the secrets. They can grab those. So you don't want to put things like your push notification gateway secrets in there to allow peer-to-peer messaging. That would be leaking those, and someone could actually crack the application, grab that secret, and message your users en masse. That's no good. Say you have a proprietary algorithm, interact with a third party, or for whatever reason, you need to expose a classic HTTP endpoint. These are all things that are hard to do on Firebase. So, in the good old days, you'll say, this was easier. My server, it's mine, I control it, I can make whatever APIs I want, I can do whatever I want to do on there. So why don't we combine them? So say we attach generic compute to Firebase, just using it as a regular old client. So it's listening to changes to the database. It's then writing into the database. In fact, until recently, this was pushed as a best practice by the Firebase team with tools like Firebase Q, where you'd write into a part of the database things that you wanted these listening clients to do, these workers. But now you have this problem again. Now you have these workers, these generic compute. You have to scale them. You have to pay for the excess capacity. And then you're going to have all kinds of troubles coming around where, oh, what if two workers are doing the same job? Then you're going to have a lot of bike shedding about the way that the Firebase real-time database is and why aren't we using MySQL. And wasn't Firebase supposed to make all of this easy, after all? It promised to make us deliver applications faster, and now we're here bike shedding, talking about how to scale these workers, and now we need to spin up a DevOps team. It's no good. So that's why recently the Firebase team launched Cloud Functions for Firebase into beta. So how Cloud Functions for Firebase works is instead of spinning up general compute and attaching it to Firebase, we have event-driven code execution. It will scale up with your usage and then down to 0 when not in use. And you're only paying for those milliseconds that you use. This allows us to provide a minimal glue that allows you to stitch all of Firebase's products together. So I mentioned event-driven. So what this is you actually write snippets of code that listen to an event. This is Node.js code. Those functions are each isolated. They're all running separately, so if one of them crashes, it doesn't take down the other. And when those events come in through PubSub, it will execute that code, and it'll either write back to the database or trigger some other action. So you can do things like listen to a database write. Then the code can sanitize the input and write to another spot on the database. So let's see this in action. All right, so here's a very minimal example. This is probably the basis example. Every time you see something, we have a hello world function here. So this is an HTTP function. This allows us to spin up an API. So this HTTP function is actually in the Express.js style. And then it sends hello world. So this is an HTTP request. It is synchronous. We don't want to be doing async work on this. We want to send a response as quick as we can. So let's jump to a more complicated example. So here's one where we're actually listening to the database. So up here, we're actually initializing Firebase functions and the admin SDK for Firebase. We're pulling in the configuration and initializing Firebase admin. We're then listening on the database, this ref, and those are wildcards. Those will be parsed into our parameters. And then on create means it's a database insert rather than an update or destroy. It sends an event object. We pull the current value. We pull the username from that, the text, title body, and we send it to the room ID on an FCM topic. So what does this do? When a message is posted to a chat room, it will notify through FCM, push notifications, all subscribers, regardless of platform, right? This could be iOS, this could be Android, this could be the web. And magically, they're going to get this. And very little code. We run this. This is an independent function. We just deploy this. And Google is going to handle all of the scaling up and scaling down as needed. So what type of things do we have? You already saw the HTTPS function. That allows you to send an Express.js response. This Express.js object, it doesn't have to be as simple as just that response send. You can actually create an Express.js application. It could be your full JSON API. So where I had that hello world, that will match any path on there. So you could just have exports API and then give it an Express application that has your entire JSON API. There's also Cloud PubSub triggers. So Cloud PubSub allows you to do durable publish and subscribe. This would allow you to take, if you do have a server, you could actually be writing to a PubSub queue and then have Node.js executed whenever anything triggers on that. Cloud storage for Firebase. So when files are uploaded, You can perform operations on them. Firebase hosting. So this integration allows you, when you're using Firebase static website hosting, to write proxy calls. So you can put in URL pattern matches that will redirect you to a specified cloud function. So I mentioned the API case. There we go. That allows you to take our static hosting and make it dynamic. There's also the Firebase real-time database, as you saw. And there's Firebase authentication. So when users are created, you can trigger code. So a good use case for this is, say, you're storing user settings or in your real-time database, and you want to set some defaults there, or you want to interact with a third party and, say, set up a customer record in Stripe, or subscribe them to your mailing list on SendGrid. You could actually do this with that, and you can actually pull in those third-party libraries. I mentioned these are Node.js. So you can actually pull in these dependencies if they have a Node.js module available on NPM. And then there's Google Analytics for Firebase. So those great Google Analytics conversion events, you can actually listen for them and trigger code. So say a user does an in-app purchase. You could send them an FCM saying thank you, or you could write somewhere in the database marking them as a VIP customer. And there's many more coming soon. If you're interested in the additional triggers that are coming with Cloud Functions for Firebase, I recommend that you join our alpha program. So firebase.google.com/alpha. All right, so I'm asking you to take Cloud Functions to your customers. It wouldn't really be fair if I wasn't willing to embarrass myself on stage. So time for a live demo. All right, so what I've created here is actually an integration with Twilio. So praying to the live demo gods that this will work. So let's start actually by saying hello. It wants me to send it pictures. Let's grab one from my web camera. Now let's see what it says. It's analyzing, that's promising. Awesome hair, that's what it picked up. Let's send it another one. Analyzing. Music. Cloud Vision didn't quite know what to think of Doc Brown. So how did I accomplish this? Let's show you the code. So here, I actually have my Twilio Messaging callback. So what I've done here is create an HTTPS trigger, Twilio Messaging callback. I glanced on this, but that is actually the root of the URL. So it'll be my Cloud Functions domain / Twilio Messaging callback will actually be the URL. And that, of course, will pattern match on anything after that part. So this would be where if you were setting up an API, you could just do /API, pass in an Express application. But in this case, I'm just going to define it all here. So I have an HTTPS on request, Express.js. So this is actually, a lot of this code here is just dealing with the format that Twilio is sending me the MMS in. So I'm looking at the number of pictures. If it's 0, I say, send me pictures, nom nom. Else, I'm going to create a payload because, well, maybe the MMSs were batched. Maybe it sent more than one at the same time. So I'm going to insert these into the real-time database. So here I go. I loop over them, add to this update payload, and then I insert it into the database. So I do an update, then I'm sending Twilio ML. So this is actually an XML API. And here you can actually see I have a little helper down here, send Twil ML, response type XML, send, and then the XML there. So that is actually inserting into the database. I'll actually show you where those are coming in. So there we have the inbound MMS. You can see them coming to the database. And I have a couple extra parameters here that were not for from and to and URL, which I set. So those are coming in from these pair of functions. So these functions here are independent of each other. They're running in parallel. They don't know about each other. They're isolated. So here, they're both listening to an inbound MMS push ID, and they're listening for that insert. So what this is doing is grabbing the image URL, and it's using the Cloud Vision API. So that's just an NPM module that I initialized. And it's doing label detection on those. I send it the image URI in the format that the API wants. And that's a promise. So I listen for the result of that, parse it, and then I write it to the database. So this event data admin ref. So these database writes, by default, are coming in as the user who inserted it into the database. So the Firebase real-time database rules will respect that. If I use admin ref, then it's saying I want to bypass these rules. This works in the context of Cloud Functions, where we're admin initialized. So here, I can actually bypass the rules. So my database rules, if I wanted, I could actually make it so that label annotations was actually not writable, but the admin ref would short circuit that. And then again, so that's grabbing the label annotations. This is also a safe search annotation. So what I'm doing there is parsing whether or not it's safe for work. So if I go back to my real-time database, we have our label annotations. So music, that's where that came from. Performing arts. Performance. Well, I guess it is performing arts and a performance, right? Let's look at our safe search annotation. So it's not very likely to be adult content and unlikely to be violent. So how did we actually then send a response back to the user? So let's take a look at our code. So here we go. We're actually responding to the MMS with labels. So a isolated function. So we're listening to the database, this inbound MMS push ID, on update. So here we're not just listening for the insert. We're listening for whenever this node in the database is actually updated. So we're pulling in the current value. We're also pulling in the previous value. Label annotations. And what I'm looking for is that the label annotations are not null and that it didn't previously have label annotations. So what I'm doing there is listening for the insert of the label annotations. From and to, I put together the body, and then the Twilio client messages create to from body. And here I'm actually returning because the database ones allow for asynchronous responses. So it expects either a promise returned, hence the return the Twilio client messages create, which is a promise, or an object. That's the return null. If it doesn't return either one of these, it's going to be treated as an error condition. So that is sent by the Twilio client API, which is just an NPM library. And I actually initialize it with functions config. So there's actually runtime config that you can set so that your secrets are not in your code. So we have this safe search annotation. Where does that come into play? That's this last function here. So here I'm also listening. And what I'm looking for is, again, the insertion of the safe search annotation. It's not an update. I'm looking at the previous value. So label annotations is null, safe search null, then we're going to return null. Else, look for it being unlikely or very unlikely. If it's either one of those, it short circuits and goes back here. So then it actually writes to a public images ref. And there, I've made a static website where you can actually see these. So it's very fast to respond here. That's actually because it's through Firebase static hosting, so it's behind our global CDN. And to prove that it's static, I can actually look at the source code. And there you can actually see all those responses. So before in Firebase hosting, you couldn't have these dynamic type responses. And this is a Node application through Express. So here, I'm actually using Fastboot middleware. This is an Ember.js application. I'm putting it on matching star. And then I'm exporting app as this. And if I go to my Firebase configuration, I'm actually rewriting the entire site to go to that cloud function. So star star goes to that cloud function. All right, back to the slides. All right, well, before we had cloud functions for Firebase, Firebase developers, in order to get any of this functionality, would have had to spin up their own servers. That's a lot of cost. You'd have to, have DevOps. You'd have to worry about excess capacity. And you'd have to worry about how to connect to this API. You'd have to respond with JSON. You'd have to worry about down network or slow network connections, whereas the Firebase SDKs take care of all of this for you. As a result, you would have a lot of complexity. Now, with Cloud Functions for Firebase, this is no longer the case. You can actually spin up robust Node.js code to listen to writes on the database. You can use the PubSub integration to respond to any traditional workers you might have. And we have the HTTPS, which take in full Express applications. And they can pull in any of the powerful libraries available to you on NPM. So I hope I was able to convince you that with Cloud Functions for Firebase, you can do all of the things, and you don't need a server.